Pierre from StackHPC. Pierre was with us yesterday in Milan. He gave a very, very interesting presentation. So,
okay, hi everyone. So, my name is Pierre, and I'm going to talk today about a migration that we did to containerized OpenStack with OpenStack Kolla. So first a bit about me. So I work for StackHPC, which is a small consultancy based in Bristol in the UK. We do deployment and support of OpenStack clouds, especially for institutions in scientific research or commercial institutions which have HPC requirements. We also do development for those use cases for research computing, and we are very involved in the upstream community. Among our team, we have many co-reviewers in Nova, in Ironic, Magnum, Kolla. And myself, I am project team leader for Blazar, which is the reservation of the service component in OpenStack. I won't talk anymore about Blazar today, but if you like the mascot, which is the lizard mouse, I've got some stickers to hand out. So the topic of this talk is based around work that we did with an institution. They had a cloud deployment which had some problems which we helped them to fix. Actually, one of the problems was related to RabbitMQ. and that led to migrating the whole cloud to be supported by us and managed by our preferred solution, which is Kolla. So a bit more details about their OpenStack. They were running the Queens release that was installed with CentOS RPMs from RDO, so installed directly on the host OS. They had quite a big control plane, 16 nodes, using lots of replicas to make sure it was highly available. So Galera and RabbitMQ, they had 3 servers each, and every OpenStack service was deployed as HA with 2 servers. They also have a Ceph cluster that is used for all the storage, and that's used by Cleanse for the images, Gnocchi for the metrics, Cinder for the volumes, and even for disks of Nova instances. So none of the data is kept on the hypervisors, it all goes to Ceph. And they had about 40 hypervisors in their cluster. Multiple generations of hardware as well, so we had to deal with things like different CPU models and different names for the network interface and so on. Their servers also went through several upgrades. I believe they installed the original one with Mitaka, so they did Mitaka to Okata upgrade at some point, and then Okata to Queens. So why would you want to containerize OpenStack? Just a show of hand, who here operates an OpenStack cluster? Okay, and who operates an OpenStack cluster that uses containers for running? Yeah, so almost everyone. So why would you do that? Well, if you're familiar with OpenStack, you probably know that it's a very complex system with lots of components, and those components have lots of dependencies, many Python libraries, and putting all of those services in separate containers makes sure that all the dependencies are isolated. You can make your deployment repeatable. You build your container images, you validate them on a staging environment, and then you can take this exact same image and deploy it in production. That's very hard to do if you install directly from RPMs. What if the mirror has changed? What if there is an installation failure, etc. And over time, it makes sure that what's happening? I have to keep moving. So over time, it makes sure that all the nodes stay the same because they are based from the same image. And obviously, we use Docker for this. So one of the solutions for deploying a containerized OpenStack is Kolla. So Kolla is the project in OpenStack, and then it has multiple software that are produced. They are called deliverables. One of the deliverables is Kolla itself. It allows you to build the container images. And then there is Kolla Ansible. Who in the room is familiar with Ansible? Quite a lot. Oh, okay. And as the name implies, it uses Ansible to deploy those images, those container images, and configure all the OpenStack services. It comes with very nice defaults. You can easily enable HA, create Galera clusters and things like that. But you can also customize it very heavily. It has three main operations. First, you do the deploy. Reconfigure is when you want to change any setting, and upgrade when you move from one version to another. You can use all the usual Ansible controls, things like tags, to limit what you want to do to specific roles, and limit by host or group as well. So if you want to learn more, you can go on the documentation website of OpenStack, and under the Kolla namespace, you'll find the documentation for both for Kolla and Kolla Ansible. Now, what is Kayobe? Kayobe is a related project which adds some more features to Kolla Ansible, and it's designed around making it easier to deploy an infrastructure, a bare metal infrastructure from scratch. So it uses something called Bifrost, which is a standalone version of Ironic, bare metal deployment service in OpenStack. And using that service, it can deploy an operating system. Usually we use CentOS on your control plane and on your compute nodes. And it interfaces with Kolla Ansible to generate the inventory that will then be used by Kolla Ansible to deploy OpenStack. It can configure the host OS, so you can create LVM volumes, configure the network, DNS, RAID, lots of things that you might want to customize for your environment. It can even manage physical devices, so we use Kayobe to configure switches as well, to configure the VLANs and the ports that are assigned to those VLANs. It can support many different families of switches, including Mellanox. And it makes it a bit easier to manage a pool of bare metal nodes as well. So that's quite interesting for people running Ironic, but you don't have to run Ironic with Kayobe. You can also use KVM for virtualization. And it has a nice CLI that looks quite similar to what the OpenStack CLI provides. And now it's officially part of Kolla, and there was a version released this summer, the first time. So you can, if you want to learn more, just go to the docs website. And just to illustrate what it allows is to take this from one node here that's Bifrost, where we call it the seed node. Originally you start just with this one, everything else is just racked but nothing else. And then you can use the standalone Ironic on the seed to deploy CentOS on all your control plane and hypervisors, configure the host OS, and all of that you can do it automated. And as I said, even the switches can be deployed and configured similarly. So for this migration, we wanted to take the current, the current at the time deployment that I described earlier, and move it to be managed by Kolla and Kayobe. There was also the purchase of new hardware for the control plane that was scheduled independently. So we worked with them to spec the control plane, and it's actually smaller than the existing control plane because we realized we only need 16 nodes for this kind of scale. So we ended up with 3 controller nodes doing all the API services, OpenStack backend services, and things like Galera and RabbitMQ. 2 network nodes specifically for HAProxy and the Neutron agent, and 3 monitoring nodes that are designed to run Monasca, which is our preferred monitoring solution with OpenStack. So that's for the control plane part. And there is also all the hypervisors. We had to reprovision them from scratch with a new CentOS image and redeploy deploy containers on all of them to accept virtual machines. And we wanted to do that with minimal impact on the users. So first, to replicate the existing configuration so that they could still go to the same Horizon dashboard and see exactly the same thing at the same address, use the same OpenRC files, and so on. And during the migration process itself, we wanted to have a short API downtime. And we wanted to make the VM inaccessibility even smaller. So in a sense, what we wanted to do is something like this. So for the migration, what we did is, we got this new control plane hardware that was set up. We configured the host OS with Kayobe, and then we start deploying progressively OpenStack services with Kolla Ansible, and we reactivate them progressively and making sure that the cloud is still operating normally. And when we're sure that it's working well, we retire the existing services that are running on the old control plane. And finally, we have a short downtime to just do the migration of the database itself. So to illustrate this, so we start from just having the old control plane on the left. All the API requests are going to HAProxy and then are forwarded to API services. There are some non-API services like Nova Scheduler also in the mix, or Neutron DHCP. And you've got the Galerized SQL database cluster and RabbitMQ. So the new control plane, we start deploying API services. So when you deploy something like Nova API, if there are no requests going to it, then it does no work at all, right? So we then reconfigure the HAProxy to point to these new API services. Some of the functionality is still managed at this point by the old control plane because, for example, the scheduler is still running on the old control plane. And that's fine because they're using the same RabbitMQ for communication. There will be an arrow between the new control plane and the old RabbitMQ cluster. And then we continue deploying more services, so we add a new Nova scheduler. We retire the old one. We still make sure that the instances are scheduled and built correctly. We enable the new Neutron DHCP, and this is just an example. There are many of those services that you have to deal with. And then when all the services, the OpenStack services themselves, are moved to the new control plane, we stand up a new Galera and RabbitMQ cluster, an HPC service, and then we're ready to migrate over the contents of the SQL database and move over the virtual IP for HPC. For the hypervisors, we don't have new hardware, we don't have 40 new nodes to move the workload to. So what we do is we use live migration. And when a hypervisor is free, we can reinstall it and reconfigure it. So similarly, here hypervisor A, we move, first we start by reconfiguring the hypervisors after the SQL and RabbitMQ migration. Then we move workload off a hypervisor, we reconfigure it with Kayobe and Kolla, and we repeat this until all the hypervisors are done. So here I'm showing it done one by one, but we were doing it in as big batches as we could. So all in all the migration of the 40 hypervisors, that took just a few hours. So some things to know if you want to do a similar migration. So first, if your config has gone through upgrade, you might not realize that there are actually some options in your OpenStack config files that are not up to date. If the options are deprecated, you will get some messages from your services on startup. It can be easy to miss them. And if the option doesn't exist anymore, OpenStack won't say anything about them. So there is this new tool in Oslo called Oslo Config Validator. It was introduced in Sane, but you can actually run it even if you have an older version. I explain how to do it in a blog post I will link to at the end. And it will highlight all the options that are not valid or are deprecated. So we used it to clean up all the config that was not up to date. Then at some point during this process, we had to tell Kolla Ansible to use some services that were not the ones that was deployed by Kolla Ansible. So for example, point to the existing Galera cluster rather than the new one. And there's two different methods for doing this. We can override directly the variables. So because it's very customizable, you can tell Kolla Ansible that you don't want to use the database that comes by default and you want to point to an external one. Or you can create groups that contain hosts that are not managed by Kolla, but they will be used to gather information. Sometimes you might have to customize Kolla images. It's quite rare because most of the config is in Ansible itself. But for this deployment, we had to customize just one image, which is the heat image, because there is one value that's hard-coded in there. And it's very easy to do. You just have to fork Kolla from GitHub or OpenDev. And modify the files, push it to a GitHub repo, tell Kayobe to use that as the Kolla source, and then just rebuild the container with one command. And we also have in Kayobe a way to deploy a Docker registry, so you can push then the images to that Docker registry. And sometimes you have to tell OpenStack explicitly about moving some resources between services. So we discovered that for Cinder, each Cinder volume is associated with a specific Cinder volume service. And you have to run a command called Cinder manage volume update host. So we had to do this before we retired completely the Cinder services on the old control plane. And similarly for Neutron, if you're not using HA, then you have to explicitly tell Neutron to move the management of networks and routers to the new agents. So to summarize, there are many benefits from running OpenStack in containers. From the people in this room, it seems like it's been adopted. If you want to use Kolla, then it's quite a powerful solution because you can customize it very well, and you can replicate an existing environment, migrate to it very easily. So by using this method, we were able to gradually integrate the new services in the existing deployment, and that was a good way to minimize disruption. And live migration is a very powerful tool. So if you don't have live migration on your OpenStack, I encourage you to configure it. So thank you very much for listening to my talk. If you want to learn more about this, I wrote a blog post that is linked here. You can find it on the StackHPC website. And feel free to contact me if you've got any longer questions. I've got my coordinates here, and maybe we have time for one or two questions.
So first of all, thanks